Hello, welcome to this video. Today we will explain the types and uses of variables in machine learning. What is a variable? A variable can be anything that can be measured or counted, such as number, trait, or personality trait. It's an element that defines something, a person, place, object, or idea. The value of the variable may vary from one sample to another. For example, variables can represent many different things: physical measurements, temperature, speed, personal characteristics, gender, age, marketing dimensions, periodicity, frequency, pixel values, etc. In machine learning, the variables are the columns of the data matrix. A variable is a vector V in Rp, where P is the number of samples in the dataset. In this regard, the data matrix contains Q variables. We can categorize variables according to the type of the data or the use in the model. Variable types. We can classify the different types of variables as numeric, ordinal, binary, categorical, datetime, or ID. Below, we describe each of these 6 types of variables. Numeric variables. Numeric variables have values that describe a measurable quantity as a number, like how many or how much. They are typically obtained by measuring continuous or counting discrete. For that, we can describe numeric variables as either continuous or discrete. We don't need to treat numeric variables before including them in the data matrix, since they are already actual values. Ordinal variables. Ordinal variables are those in which we can establish a precise order. For example, the education level, elementary school, high school, graduate degree, or the economic status, low, medium, high, are ordinal variables. We can easily codify ordinal values as numeric values by sorting them according to their order. For example, we can assign the number 1 to the first value, 2 to the second one, 3 to the third one, and so on. Binary variables. Binary variables are those that have 2 classes. They usually indicate the absence or presence of some categorical effect that may be expected to shift the outcome. For example, a patient may be positive or negative for a given disease. Another example is that a customer may or may not have purchased a product. In these cases, we label the positive values as 1 and the negative values as 0. Categorical variables. Data consisting of a limited number of positive values can be considered categorical data. Categorical variables don't have an exact order. Categorical data can be viewed as aggregated information divided into groups. For example, marital status is a categorical variable whose values are single, married, and divorced. Encoding categorical data is converting categorical data into integer format, so that the data with converted categorical values can be provided to the models to give and improve the predictions. For the case of categorical variables with 2 classes, C1 and C2, we can codify one class as 0 and the other as 1. We must code the data with the one-hot encoding scheme if the categorical variables has more than 2 classes, C1, C2, Cm. In this encoding, each category of any categorical variables receives a new variable. It assigns its category with binary numbers, 0 or 1. The following table illustrates the one-hot encoding. After one-hot encoding, the number of resulting variables is the number of categories. In this way, the variable of a sample j are Vj is equal to 0 when xji doesn't belong to ck and is equal to 1 when xji is belong to ck. Datetime variables. Datetime variables includes a calendar date and a clock time. It includes in single string information about the year, month, day, and second. Human-readable datetime variables are converted to Unix timestamp variables. Unique timestamps are a way to track time as the total number of seconds running. These variables are not included in the model. Constant variables. Constant variables are those columns in the data matrix that always have the same value. They should be set as unused since they don't provide any information to the model but increase its complexity. ID variables. The ID variables identify the samples. These variables are not part of the model. Example, bank marketing variable types. A banking institution conducts a customer segmentation study to identify the people most likely to be interested in a specific product or service. In this way, the bank creates a model to predict which customer will subscribe to a long-term deposit and which will not. The variables included in the dataset are the following. The variable age is numeric. The variable marital status is categorical. It takes values such as divorced, married, and single. The variable default is binary. The variable balance is numeric. The variable housing is binary. The variable loan is binary. The variable contact is binary, and the last one, the variable conversion, is binary too. Variable uses. We can discuss input, target, or unused variables regarding their use. Each of these three uses of variables is described below. Input variables. Input variables are the independent variables in the model. They are also called features or attributes. Input variables are denoted x. The number of input variables in a data matrix is denoted n. Target variables. Target variables are the dependent variables in the model. Target variables are denoted t. The number of target variables in a data matrix is denoted m. In approximation problems, targets are continuous variables, power consumption, product quality, etc. In classification problems, targets are categorical variables, fault, churn, etc. In this type of application, targets are also called categories or labels. Unused variables. Unused variables are neither inputs nor targets. We can set a variable to unused when it does not provide any information to the model, ID number, address, etc. In this regard, we can define a variable using a vector as follows. The size of this vector is q, the number of variables in the dataset. Note that a variable cannot have two uses at the same time. For example, we cannot use a variable as input and as output at the same time. Conclusions. Variables are the column of the data matrix. We have different variables depending on whether we classify them by type or use, and it's advisable to carry out a study of these variables before the model.